Hello, everybody, and welcome to today's Volta TST call. Thanks for joining. As usual, the call is public and recorded. It will be shared live on YouTube, so please be mindful of the comments you make and the information you share. First up, as a topic for today, we have the conclusion of the reconciling patches, in the sense that the current set of patches that were up there from Maninder were merged, and this is great news. It's very good that we got them in, so they can undergo thorough testing before they're released. Thanks a lot to Maninder and David as well for pushing this through reviews and implementation side.
And for all the reviews he did as well.
Oh yeah, absolutely.
And I think Mahir and Ahmed, a lot of people helped out. Great. A lot of people helped out.
Indeed. So thanks a lot, everybody, for pushing those. There's still, I think, one patch that needs to go in the core for handling the failure of the reconciliation, especially against the ONUs. We might discuss that on Wednesday tomorrow at the Open ONU call. I know Holger had some thoughts on that, but it's very good that the first set of patches go in. Okay. Before I go forward, any questions on this one? No? Okay, then if not, next up, very briefly, multi-uni support. We merged a couple of patches, one that was important in ONOS for the annotating the meters, one in the OpenONU Adapter Go. The other one on the OpenONU Adapter Go is fairly close to being merged. I know Mahir is working on it, and he has some more implementation, just rebasing to do, and then I think we can go through the testing, and if it looks good, we can just go ahead and merge it. So it's very close. There's some other work that needs to be done, but there's also an initial implementation patch from preparatory patch, maybe from Theo on BBSim. So if anybody has some time, just go ahead and take a look at this and review it. Mahir, Theo, anything to add?
No, nothing, Andrew.
On the BBC side, there is that patch that is really preparatory work, and there is another one that I'm going to link in the notes. That is the first draft at really supporting multi-uni. Is that one moving services? Thanks.
Thanks, Theo. I'll take a look at this one as well. And if anybody has time, please do devote to it. I think it's a fairly involved patch, as we were discussing. So it needs careful review, but the more eyes we put on it, the better we can achieve result we can achieve.
Yeah, the second one, just a heads up, is still very much a work in progress. Working, it needs some cleanup. So I'll do that today.
Andrea, did you hear me?
We can hear you now, Mahir, yes, but we didn't hear you before.
Okay, thank you. No more comments on this.
Okay, thanks. Then please take a look whenever you have the time.
Sure, okay.
Great. Okay. So next topic, which is the big one for today, which I wanted to address with everybody, is the storage discussion. There's been some great work from both Ken and Girish on optimization at the OLT adapter level and the ONU, and the RW core level for the amount of data we're storing in a TCD. So Girish, Ken, do you want to take it forward?
Yeah, let me present.
Thanks, Girish.
How? I think you need to make me host or something. I cannot share anything here. Okay, I can see now.
Should be able to share now.
Yeah. I hope you can see the document that I'm sharing right now. Are you seeing it?
Yes.
Yeah,
Cool.
we can see.
Okay, thanks. So last week we didn't have the meeting, and the week before that I shared some thoughts about what are the places that we could enhance in read-write core in the OpenOLT adapter. So I shared some thoughts about it, and during the last couple of weeks we went about doing some work regarding this, trying to not persist some of this information and see what effect it has on the storage. Thanks to Ken as well for providing some patches on the read-write core. So here I'm going to discuss some of the results that we have. There is some good news, but there is also some not so good news. So yeah, let's go into those details. The first thing was without any enhancements. So what was the DB size and the key count on the etcd? So the number of subscribers is 1024, 512 across 2 OLTs. The workflow I chose was AT&T, and the Jenkins job is here. So the DB size was about 134 megabytes, and the key count was about 48,373. I'm
Is
going to
this
make
with
some note
any
about
setting?
this DB size later in the discussion.
Is this with any the settings for I can't think of the word right now, where the
Compaction.
Thank you, compaction and or defragmentation running?
Sorry, I think my internet was a bit unstable for some time. What was the question?
I was wondering about the compaction settings as well as if defragmentation was running.
Well, it was in its default setting. I'm not sure what that was. I don't think you're enabling auto compaction.
It's
right.
without compaction, David.
No. It is with compaction without the fragmentation. That's the default in the scale test.
And the compaction's defaulted to, I can't remember, is it an hour?
It compacts every 5 minutes down to 1,000 items.
Okay.
But this is not with the compaction patch that Maninder worked on, which uses the new etcd charts, right?
No.
Okay.
Well, one of the job I think it was.
Yeah, but let's not consider that for now.
No, that's still with the old non-Bitnami charts.
Okay. Thanks, Tio. Should we proceed ahead?
Yeah, thank you.
Okay. Okay, so now we started doing the enhancements, and the first step was, I did some changes in the in the OpenOLT adapter. First was to remove the map of ONU ID, UNI ID to PON interface ID, gemport ID mapped persistence on the etcd. Removal of storage of NANA interface IDs per OLT on the etcd. Removing this map of PON, ONU, UNI, VLAN, PCP to gemport ID. And the next item, this was a big chunk item. So, removal of storage of physical device flows on the etcd. And then also, compaction of the meter information that we are storing on the etcd. So this was not totally removed, but yeah, it was compacted on the etcd. So what I saw was, the DB size was now about, 114 megabytes. This was about, 15%, reduction from the total size. And the key count was about 43,000. This was about 11% reduction from the original count. And then we proceeded to the next step.
This is interesting, actually. So I expect, without the physical device flows, I expect more reduction, actually. Isn't it right?
Yeah, pretty interesting. So that's what, I want to, I have, some questions about how, etcd, shows up this device size in the metrics. I'm really not sure. I'm going to make a note about that later in the discussion.
One question that I have too, is there a minimum under which etcd does not compact?
What do you mean?
I don't know, under a gig, it doesn't run the compaction at all.
Compaction is not really about the size of the database. It's about the history. So we are compacting down to 1,000 keys. So I'm assuming that if there are less than 1,000, sorry, not 1,000 key, 1,000 commits. So I'm assuming that if we have less than 1,000 entries in the history, we're not. I don't think that's the case.
Okay, thanks.
Yeah, actually, I want to make it clear that compaction doesn't decrease the size of the DB. Actually, I have read in somewhere, I don't know where, the compaction actually might increase the DB size. If you do the fragmentation, then the compacted, you can get rid of the compacted data. etcd still stores the compacted data in its database, so it doesn't decrease the database size, as far as I know, as far as I read.
Yeah. Defragmentation is key if we're trying to reduce database size.
Yes, correct.
Yeah, that's interesting, because I have been seeing, some erratic, results about this DB size, which I'm going to, show here in the last step. This has not been consistent. Sometimes even after, all the enhancements, it has been, the size of the DB has been much more than it was, without any enhancement. So which is really surprising and didn't make much sense. So probably what you're saying here is, the compaction is in a way actually increasing the DB size.
To manage your DB size, you have to do both, right? You do have to manage your compaction, but you also have to do defragmentation. I don't think it's an either or issue.
This is what I find in my environment. If I do only one of them, it's the same. If I do both, then the size decreases.
Yeah, probably I'm going to do that, as sort of a next step.
But irrespective of that, the idea of reducing what we're storing is a great idea.
Yeah, of course. Okay. So that was a second. Now to the second step. Thanks to Ken, he provided an image of OF agent and read write core. With the support of removal of storing of device and logical flows.
Yeah, just one thing that Girish, it's remove device flows and logic.
Yeah, sorry.
Not device.
Yeah, device flows and logical flows.
Yeah, I also removed the meters and any groups, but there was no groups and very little meters.
Yeah, Yeah, the groups come in play only with the Turk Telecom workflow because of the multicast stuff. The meters, so there's usually like, it could go as high as 2 per subscriber, but it's usually depending on the bandwidth profile that we use, and we usually like use a couple of bandwidth profiles and a default meter, so it's like 3 meters.
Okay. Yeah, thanks, Andrea. Thanks, Ken. So now the DB size was about 91 megabytes. Sorry. Okay, so now the DB size was about. Is someone talking?
No, go ahead, Girish. I think there's somebody not on mute.
Okay. So the DB size was now about 91 megabytes, about 32% reduction. And the key count was about 28,863, and this is about 33% reduction. What I see is, the key count, this is pretty stable. I mean, if you run multiple times with the same set of changes, the key count always remains the same, but DB size, for the reasons that you guys mentioned, this is pretty erratic. I mean, sometimes I see more, sometimes I see less. Okay, so the next step was
Girish, sorry.
Go ahead.
Yeah, the device flows removed here and the physical device flows removed in the previous step.
Yes.
Yeah, what's the difference between them? I mean, are they same or different?
No, they're not same. So the physical device flows are actually the flows that are actually installed on the OLT. I mean, this flow definition is actually what's defined in the OpenOLT.proto definition.
Okay.
This is actually an open flow.
Okay, thank you.
The last step was, the tech profile instance was not persisted on the HCD anymore. But in place of it, we now store a resource instance, which is just the gem port and alloc IDs. And the tech profile instance is generated through a combination of the tech profile template and the resource instance. This has much smaller memory footprint compared to the tech profile instance. The tech profile instance had a lot of duplicate information, which was just a copy paste from the tech profile template. So we didn't really need to store all of that.
So we were generating stuff from the template and storing the result in the database.
Yes.
And everything. We just generate that on the fly.
Yes.
All right. Thank you.
But we do persist, a resource instance which has, the gem port and alloc IDs, which has a much smaller footprint.
And that resource instance is really the object containing the 2 elements for which we need the strong consistency. That is the case,
Yes.
right?
Yeah.
Okay.
After this, the DB size is about 90 megabytes. And at this point, I begin to think that, this DB size is probably not the right metric here with, the set of settings that we are running. We are enabling compaction, but defragmentation is disabled. So I saw an improvement of about just 1.5% from the previous run. And the next time I ran this, the test ran successfully, but the DB size was, back to 115 megabytes, which was more than without any enhancements. So probably this is not a right result. Yeah, but nevertheless, all good enhancements and, all the tests actually ran fine with these enhancements. There was no reduction in the key count because we were storing the resource instance in place of tech profile instance. So the key count remained the same, but generally I would expect, the DB size to actually reduce. But here we don't see it. Probably that's because of the test setting that I have in my pipeline. Well, the next steps are I really need to investigate if we could optimize a bit more, because if you see this table, we still continue to persist some of the information that's mentioned here. We need to see if we could live without persisting that, and one more thing was to enable persistence. Maninder had a patch to. I'm not sure. I mean, if you're already enabling persistence, then what's the Maninder's patch about? I mean, he has a patch to enable persistence and also to use the latest HCD charts that has auto compaction feature enabled.
Yeah, I thought the existing charts didn't have, was it auto compaction or some other setting allowed to be set? And that's what he added.
Well, I actually used that patch in my pipeline, and the test never succeeded with that patch.
Really? Because it's been merged into the latest etcd Bitnami charts. So you try to make sure you're using the latest chart, published chart, as well as the latest published etcd image. And there have been improvements to both that should help.
Well, I actually used, this particular patch in my test pipeline, and it never actually ran fine. Well, if this patch enabled both compaction and enabled persistence as well as auto compaction, I would have expected to.
Okay. What errors were you seeing?
Well, honestly, I didn't investigate the logs.
Okay.
I'll do so today.
All right. And I'll touch base with Maninder and make sure that the latest needs to use.
And yeah, one more thing, as you guys suggested, was to enable both compaction and defragmentation and see how it goes. With this, I expect to see some consistent dB size reduction with various enhancements that are carried out.
The interesting thing will be the period for defragmentation, because when you run defragmentation, the database is essentially locked during that defragmentation process. So there'll have to be some experimentation to figure out what the right settings are for some of that.
Something else, that I would consider is not just the amount of data we store, but also how often we read and write it. It could be that we are accessing less data, but the speed at which we require that data is still so high that with persistency on, we are not able to serve it properly. I don't know if I'm making any sense.
I think you're making sense. I've been assuming that most of our operations are read operations. That may be a faulty assumption. So I wouldn't think read is affecting our database size, or I wouldn't think that'd be the issue. I think it would be around writing.
But given what Girish has shown us, that the DB size, even without with all the improvements, is not that lower than what we started with, could it actually be an operations issue rather than a size issue? Making the size smaller, great, but maybe it's not just the size; it's also the amount of read write that we do, because effectively, when you write, you cannot really read because it's a strongly consistent database. So
Karthik was doing some experimentation around etcd, particularly with Kubernetes, because Kubernetes uses etcd as its object store. Now, it may have different operational requirements you have, but they within Kubernetes, their database size doesn't seem to grow to the same extent we did. He was even creating custom resource definitions and banging away at updates on them. it does. So there's some element of configuration around what we're doing. And it may be that there's also some issues around operations in terms of, are we writing objects that we've already written and haven't changed? There may be some thinking around that as well. Kubernetes has, a single point that does it. Each master is writing the etcd, so it's coming to the API. So they're kind of the same situation we are.
But there is a fundamental difference, though, that etcd in Kubernetes is generally deployed directly on the host. It's not running on a container.
What do you mean? It's etcd in Kubernetes is running as a container, I thought. What do you mean it's running? I don't think.
I guess it depends how we install Kubernetes.
Yeah. So again, I think this will be interesting. The most interesting case will be if we can get the compaction setting correctly and maybe less than a smaller value than we're setting it now. Again, experimentation, kind of seeing a table. What are we seeing in database size with these tests when compaction value is 1 minute, 5 minutes, 10 minutes? And then of course, how does that change when we run defragmentation 1 minute, 5 minute, 10 minute?
And again, I would really like, while we do these tests, to keep an eye on the IOCTL really of the disk. Input, output, read and writes. There's a metric for this, which we have in the scale. Maybe it would be interesting to see how this compares from a run without the improvements, Girish, and with a run with the improvements. That would be good, because if we don't see that much difference, then maybe we really need to focus as well on that one. Maybe this is just my idea, but
I think it would be good to watch that as well. Any feel by anyone for the cost of storing protobuf definitions as opposed to, I guess, storage specific objects?
I think protobuf should have a less memory footprint, right?
Yeah, protobuf is in bytes. It's already compressed. The only thing is, in terms of etcd storage per se, it won't make a difference in the sense of what maybe, but every time we write any bit of information to etcd, it creates a revision. So it means it saves something. So there's extra storage that is created as part of that. Maybe one thing that we also need to check in our code, if we're overwriting data that doesn't need to be written, maybe we need to have a check there. If data has not changed, there's no point of writing it. That will create less revision, because when we look at the number of revisions on those data objects, they're fairly high. It means there has been a lot of writing to any of those objects in etcd.
Is there a setting on how many revisions that we can store on etcd? I mean, there's no point storing hundreds of thousands of revisions.
No, that's what compaction does. You cannot
okay.
round what the limit is.
Got it.
Regarding protobuf, I wonder if being protobuf already compressed, etcd cannot really figure out a diff between the data, and so the compaction size is, the revision size is much bigger than it will be for plain text.
Yeah, I think if we move away from protobuf and we use something more transactional, then I think we need to also move away from etcd, go more to a transactional database.
agreed.
Just having key values, so no matter what we do, no matter what the structure it is, it will still be key values. It will still be data that is a bunch of revisions in etcd.
No. But I guess the question is, instead of storing a protobuf, would it be better to store a JSON document, an XML document for the object? Would we get better performance, better size optimization from NCD if we stored that as opposed to binary?
Yeah, so my point was based on the fact, like when you store binaries in Git doesn't really keep track of the diff. It's considered an entirely new file. While when you store a readable file, then it only keeps the delta between the two files because you can figure that out.
It's a good guess. What we could try, I mean, we have the place exactly in Voltha Go to do so. We just convert it to JSON or XML before storing it into etcd, and we convert it back when we read it. We pay the cost of conversion, but maybe it helps. It's a worth trying as well.
And in that same spot, we do the conversion. If we wanted to test the what Ken mentioned, only write when there actually is a diff, we could always add a read then write mechanism.
And Girish, please put in the next steps, that monitoring of the read and write.
So regarding the previous point, storing JSON versus XML versus protobuf. So are you suggesting that JSON or XML would take much less memory footprint versus protobuf on etcd?
No, it's not about the memory footprint. It's about the fact that with bytes, you cannot really perform a proper diff. Instead, if etcd is intelligent enough to perform the diff against the JSON file, you could do that. While with the bytes, you cannot really do a diff.
Yeah, got it.
Because you don't know the content, even though it might be similar, you don't know what is difference. Instead, with JSON or XML, you actually know the difference between the elements. As Theo was pointing out, it's the same thing that when you do a patch for Voltha Produce in Gerrit, the compiled binary of the pb.go, it just says binary in Gerrit. It doesn't show you the difference, while everything else is shown. So maybe that's also something that's worth investigating.
Do we know if etcd does that though? If it actually tries to do a diff and only updates?
Yeah,
I personally have no idea. It's worth investigating before we make any changes.
And that's why if it does, great, that would be wonderful. But if it doesn't, even in that same spot where we're doing that conversion to JSON XML, again, we could do a read the item, diff the item in memory, and only write if it actually changed.
Yep, that's also a good thing to do.
Yeah, I've never read it in somewhere. What I know is every write creates a new compaction, whatever the data is. It doesn't compare the data between the revisions as far as I know. I don't know specifically, but I didn't read it anywhere.
Yeah, I think you're right. I haven't seen that either, which is why I say if we really want to only write when there's a diff, I think it's going to be up to us to do so.
Yeah, that's also what we are seeing in our test, isn't it? I mean, we see a lot of revisions of data in the database.
And this is a real easy test, right? We don't even have to do it in Voltha. We could just run something against etcd and then look at the revision number.
But if we are seeing a lot of revisions, then I come back again to my point. We are doing a lot of writes. So
Yes,
that needs to be investigated.
Yeah, I think we are doing a lot of writes because there are a lot of writes everywhere in the code. We change the device statuses very frequently, reasons very frequently. The maps in the OLT adapter, they change very frequently, I think.
So we are storing the flow data as protobuf objects, right? That is, I think that is why we are seeing not more reduction in the DB size when we doesn't store the flow data.
Yeah, any data is stored as proto, so it's including flows data.
The adapter, stored all data as JSON. It was not using single bar. But about 75% of the adapter's footprint on the memory has been now reduced. It's storing very minimal data right now. Well, it's not directly there is another huge chunk of data is the resource pool, but that's sort of static. I mean, it's created once the system is brought up and it continues to stay there. But a lot of transactions happen on these resource pools, the gemport, lock ID resource pools. So I believe a lot of revisions of these resource pools are created on the HCD, and that probably is also contributing to the size. But I have no definite data to prove that. But yeah, that sounds logical.
So given the amount of writes that we are concurring that we are doing, it's probably worth checking if some of these could be avoided, maybe. The ones that are not needed for reconciling of a container upon restart, we can skip that and keep it in memory.
Right. Yeah, I think, whatever was possible, I think we have done that, but, I can go back to the table and see if we could, do away with some more things.
So maybe some optimization as well, like for the device reason that Mahir was pointing out. Instead of rewriting the whole device structure under the key, we might want to have like, I don't know, a map of device ID to reason that could just be that one. It would need some updates and changes within the code, maybe, or just in the library, but it would maybe help us to avoid reading and writing the whole big device structure, which is fairly involved at the moment.
Well, the thing is, we really don't know. I mean, if that is a problem. So, I mean, there is no strong proof as to which particular item is actually contributing to these some of these issues. Okay.
I think the real issue is frequency of writes rather than the DB size. If we decrease the frequency of writes, then we can also get a smaller DB size, I guess.
Yeah, right. Because that means less revisions, no?
Mm-hmm, yes. So I have a different question. When we actually I was gonna ask the question in the last meeting, but there was not enough time. So who will be responsible for pushing the flows again on us when we doesn't persist them?
Right.
So is it something working right now?
Yes.
Or do we? Okay.
Yeah, it's working.
One patch I need to push, but it works.
Yes, exactly. So there's this small patch from Ken that fixes a bug where we're actually no flows. We were not reporting the stats. He did some testing. He found out this issue. Thankfully enough, he fixed it fairly easily. It's a small issue in the OF agent. The patch is up. There's some comments from me and David. But as soon as that gets resolved, it's minor code comments, the functionality works. That will be merged and it will allow us to repush the flows anytime the core goes down without having to persist them at all.
So the place where we trust the data about the flows will be ONOS then.
With this announcements, yes.
Yeah. Okay.
What are your people's thoughts about merging all, getting in all the enhancements that has been carried out until now to the main line? Well, there has been some drastic changes. For example, the whole tech profile library had to be rewritten because there was a lot of dependence on storing TP instance on the etcd. Now that is all stored in cache, while a new data structure has come in its place, the resource instance. So there has been some drastic changes. So I can upload all these changes for review, but what are your thoughts about getting in these changes to the main line?
I'm personally in favor of putting in the main line. I'd like to make sure we do a scale test first because some of the changes may have impact on performance, particularly the tech profile one, because we're generating on the fly. If we could just do a performance test to ensure that we're still hitting the same performance numbers, that'd probably be good.
Actually, if I'm not mistaken, David, the tests are actually at scale. They're actually running. I think Girish and Ken are running them on the AT&T workflow. We need to run them on the DT workflow and the Turk Telecom workflow. And before we merge them, I would like to run them on all three hardware tests. So hardware pods for DT, AT&T, and Turk Telecom. But if all of these passes with the existing figures that we are pursuing, I would say we are okay merging them. Does that make sense for you?
Yeah, I think it does, and it's better to merge them before we do the LTS as well as before we get too many things that we have to rebase.
I'll add one extra test to that. It's because the whole thing was based on a restart. So we need to do a restart test with a fully loaded system to make sure that the time that, for example, it flows, that they get pushed, that is reasonable time.
Most of the edits here are affecting, the restarts and reconcile cases. So we have to do detailed tests about reconcile cases.
For the reconciliation cases, we do have some tests that use a couple of OLTs with some ONUs. I don't remember the exact number, and both single OLT and double OLT, where we run the full smoke suite, entire big full tests. So that can be used. I do agree, Ken, that it would be nice to accept to the scale tests, or maybe even run it manually once the system is provisioned, to make sure that the RW core restart still supports the 1,000 customers per stack that we are pushing at the moment.
Yeah, for me, it's more like I know it. I test it locally. Those flows get pushed. It's more like to make sure that there's no service impact and the time it takes to push all the flows to all a fully loaded system. It's okay.
By the way, so
on the service impaction thing, that will be tested when we run these patches on hardware, because we do have our RW core restart test where we expect that no flows change on the ONU.
Okay.
So yesterday I ran 1517 through 1520. So these were the runs with all the enhancements in place. So they ran successfully. This was with AT&T workflow, 2 OLTs, 16 PON ports, 32 subscribers, 1024 subscribers in total. So this ran fine. I'll run this for other workflows as well and see how it goes. as well, use these enhancements on our nightly sanity, the functional error and failure scenario tests as well, and see how that goes.
Do you also see a performance improvement, by the way?
Well, the thing is, I don't really see any change in the amount of time it takes to run the tests. So I'm not really sure how else do we measure the performance. Well, one thing was to see the HCD metrics. The key count was consistently reducing with all the enhancements, but the DB size was a bit erratic, and that's probably due to the test setting that we just discussed. Well, do you have any inputs on how else do we measure the performance? Probably I could.
I guess we should be able to compare the older results, but Matteo knows better, I guess.
Okay.
And we will do these tests with the defragmentation enabled, isn't it? I mean, as far
No,
as
it's a manual process, Maish.
it's manual?
Yes. Compaction is auto, but the defragmentation, you should do it via HCD CLI.
How can we use this
Really?
operation? I mean, it's
Yeah, it is. It's not an auto operation. The defragmentation you cannot do automatically.
Well, you can schedule it as a cron job
Maybe
in,
yes.
in Kubernetes and run it that way. And that would be the way to do it.
Yeah,
either that or you'd have to have some other process, you call it.
Okay. Yeah, that's interesting. I thought it's just some setting in the Helm chart.
No, it's a separate executable you have to run.
Interesting.
And do you have any experience about it? How long does it take, and does it stop the world or not?
It does, to my knowledge, stop the world. How long it takes is dependent on many things, including your compaction size and database size. So that's why I say I think we're going to have to come up with a chart that basically says for the different values settings, what do we see?
Yeah, I tried with 20 gigabyte size of database, and the defragmentation fails. I experienced that, but with the smaller DB size, it shouldn't be a problem. But bigger DB sizes, it definitely takes some time, and also it can fail.
You also want to check which version of etcd you're using, not necessarily just the chart version, but the actual image version. I think Karthik was saying there are some changes, and you want to make sure. I think he says by default we're using an older image of etcd, and we'd be better off using a newer one.
Well, did I hear that we cannot have any transactions on the etcd while the defragmentation is in process?
Yes, that's correct. That's why, again, why we need to experiment how often we defragment, as well as our compaction size.
Okay.
And I don't think it rejects transactions. In other words, if it's a defragmentation and you set a transaction, I don't think the transaction fails. I think it won't go through, so it's blocked. And so with R, I think we default to 10 seconds for our context. As long as defragmentation happens within that time frame, we should be okay. And again, it's good experimentation.
Another problem with defragmentation is also you have to do the defragmentation on each instances of the etcd.
Okay.
So,
is it on each instance, or it's not just a single executable with the defragment small? No, I'm not sure.
As far as I know, you have to open a CLI screen from one etcd instance and then run all of the comments separately on each instances.
Yeah, that's different than what I've seen. I guess I've just, okay.
Well, still, I'm a little torn between, I mean, a little confused with the results as I just mentioned. So the defragmentation, when the defragmentation is in process, I hear that there are no transactions possible on the HCD. I mean, that seemed a little concerning to me. And without that, you know, the DB size was pretty erratic. And I mean, the whole point of this was to, you know, reduce the DB size as much as possible. I mean,
There's just etcd, like any database, takes maintenance. This is one of the maintenance things it needs to do.
okay. Yeah, I mean, there needs to be a maintenance window for, you know, defragmenting, but
It's, again, it's not necessarily a maintenance window. It's, you have to call it periodically. So it's not like you're gonna say every night at 2 a.m. we're gonna run defrag.
okay.
I don't think it's gonna be like that.
Okay. Yeah, I'm going to, Sarkant, I probably am going to reach out to you. I mean, if you have done some experimentations with, you know, defragmentation, so I
Yeah,
might
sure.
need some help from you here.
Yeah, of course.
Well, that's all I had to present. Oh, one more thing. Ken shared this data here. I mean, this is without any enhancements. So he ran a little the query on the HCDB and, you know, tried to pull this information. It basically shows, you know, which components are occupying how much percentage of memory on the HCD, you know, what are the number of keys, the sizes, the percentage of data. So this is pretty interesting, and this could be useful to see, you know, which places that could use some enhancements. Pretty interesting data.
And what's interesting with this, it's this is just like querying the data from in etcd. The data itself was a tenth of what etcd was showing. If we look at the size in etcd and then we look at the data size here, it's a tenth. So etcd was storing a lot of information. So obviously this data is not based on defrag and all those things. So it's
Okay.
once that done, I guess the database will be down by tenth, but more than a tenth.
Also, I saw that there is some stuff in the OpenONU that you suggest as minor improvements, Girish. Something that's not used anymore because you push down to the OLT agent. Is that something we could look at doing as well?
I'm really surprised with this data. I mean, OpenONU is not really storing that much of information, but it still is about, you know, I mean, if I see here, it's actually a significant portion of the percentage of data. So I'll be keen to look at what is it actually storing.
It may be the MIP database.
Well, the MIP database, it's one per model of ONU, right? I mean,
No, not MIP template. You know, it creates the instance of MIP template and keeps the instance per ONU.
Okay, interesting.
As far as I know, I mean, it's like technology profile and technology profile instances. The template is a template and doesn't have some actual values per ONU. Then you create an instance for ONU itself. With
Got
its number is something, some other resources, you know.
Yeah, probably it's the instance of the template, but
Yes.
I probably missed that in my study. I thought that was not getting stored. You know, thanks, Mahesh. I'm not sure how to optimize that. Let me think about it.
So, Girish, one question. So, did you get a chance to look up the number of keys as a function of the number of ONUs? Because even after all the optimizations, I think there are about 28,000 keys, right? Still, the key count.
Mm-hmm.
And we have 1,000 ONUs in the system.
Mm-hmm.
So how much of this is a function of the number of ONUs, right? Because that is something that is going to grow linearly, right, as the system scales up.
Right.
Are you looking for the key counts?
Yeah, on a per ONU basis. As a of the number of
Because in the
ONUs.
list below, you'll see the number of keys. Like for example, for Open ONU, that's the number of keys that was stored for 512 ONUs.
Yeah, I think if we add up all of these, it should come to something around 12 to 15,000. But the total number of keys that we have is 28,000. So I think we still are missing a big block of the keys.
This was for 512 subscribers.
Okay, then maybe it's correct. Yeah.
Yeah. Well, if I see the keys here, I mean, it all makes sense. I mean, a technology profile. These are basically, I think, the instances. One instance per ONU. Yeah, I mean, if I just look at this sample and devices and the logical devices, adapters, I mean, I think it all makes sense.
Four logical ports. Okay.
Well, the logical port is 2049.
That's 4 per ONU.
Because on BBC, when we register an ONU, and when you have multiple unis, they're not activated.
Ports. Yeah.
Each one of them has a port.
Got it.
And it seems ONU keeps, Open ONU keeps 5 keys per ONU.
Okay, so I think this matches. I think we can find out as a function of the number of units. That's good.
That's all I had to present. Back to you, Andrea.
Thanks for doing this. It's actually really good stuff.
You're welcome.
Yeah, thank you, Girish. Really good job.
Andrea? I'm not sure if he's still on the call.
It looks like he left the building.
Was in a park, so.
No, I know. It sounds like he's wherever he is. It sounds like there's a good time going on.
Yeah, he was saying it's a good weather over there, so he was in a park.
Okay, so I'm going to stop recording, and I don't know if I can stop that. Yeah,
I'm going to say that a kid probably stole his